Welcome to Inscribed Angles. Our objectives today are to understand the relationship between a central angle and its inscribed angle. Also, to know the relationship between inscribed angles that intercept the same arc. And finally, to use all those relationships together to solve inscribed angle problems. Let's start off by watching a short video about central angles and inscribed angles.
In this video, we are going to learn about inscribed angles and circles. First, let's review what a central angle is. If you have a circle, a central angle is the angle formed by the center of the circle and 2 points on the circle. So this would be one example of a central angle. And remember that the measure of the arc that is intercepted, so this arc right here, is always the same measure as the central angle here. Now, if instead of connecting these 2 points on the circle to the center, we connected them to a point across the circle, like this angle created right here is called an inscribed angle. And an inscribed angle is always half the measure of the arc. The central angle is the same as the arc. The inscribed angle is half the measure of the arc. Okay, so for example, if this arc was 100 degrees, then this angle, the central angle, would also be 100 degrees, but the inscribed angle would be 50 degrees. Now, the cool thing about inscribed angles is if you have a circle and you pick 2 points on the circle to make your inscribed angle from, there are an infinite number of inscribed angles that you can draw from those 2 points. For example, you could have an angle over here. That's one inscribed angle. Or you could have an angle down here. Or you could have an angle over here. And as you can see, you could keep going and create more and more angles. And because all of those angles intercept the same arc up here, it means that they all must be congruent because they're all half the measure of that same arc. So that means if this arc was 90 degrees, then each of these angles would have to be 45 degrees, half of that arc. Also, if you didn't even know what this arc was to begin with, you would know that all of these angles have to be the same. Now, what if you had a circle and the arc that you were thinking about was actually a semicircle? It goes through the center of the circle. So you're thinking about this arc and an inscribed angle from those 2 points. So for example, this right here. Because a semicircle is 180 degrees, it means that this inscribed angle has to be a right angle. So in general, inscribed angles of semicircles are always right angles. And this is important to know because you'll oftentimes see a picture of a circle and you'll know where the diameter is. And you'll see an angle that's been created in half the circle, and it won't tell you that this is a right angle, but you have to realize that it has to be because it's an inscribed angle for half the circle, for a semicircle. So it has to be 90 degrees, which is half of 180 degrees. So in general, what you have to remember is inscribed angles are always half the measure of their arcs, and that means that any inscribed angle from the same 2 points will always be congruent to any other inscribed angle from those 2 points. And if the arc happens to be a semicircle, then that inscribed angle will always be a right angle.
Now you understand the relationship between an inscribed angle and its central angle. Let's try a few problems. In our first problem, if the orange angle measures 28 degrees, what does the blue angle measure? Well, notice that this orange angle right here is an inscribed angle, whereas the blue angle is a central angle. They both intercept the same arc, however. So pause the tape for a second and think about that. Remember what you just learned. The inscribed angle is half the measure of the central angle. So if this angle in here is 28 degrees, then we know that the central angle is 28 degrees times 2, or 56 degrees. The arc, the intercepted arc, would also be 56 degrees. Let's look at the second problem. In this problem, we want to solve for this question mark. We don't have a central angle drawn in. We could draw it in, but it doesn't really help us. The information we have is the arc length, or the arc measures, I should say, for these outer two arcs. What we're missing is this arc, which could help us find the intercepted or the inscribed angle. So, think about how many degrees are there in an entire circle. There's 360. So if we take 360 and we subtract these two arcs, we'll be left with 104 degrees, an arc measure of 104 degrees up here. Well, if we know the arc measure, we can figure out the measure of the inscribed angle. Remember that this arc measure is going to be the same as the central angle. If I were to draw in the central angle, that central angle would also be 104 degrees. But the relationship between the arc measure or central angle and the inscribed angle is that the inscribed angle is half. So to find this, we would take 104 divided by 2, and we would find out that this angle measure here is 52 degrees. Let's try a few more. In this first example here, we need to once again solve for this question mark. Well, let's think about what we have. This question mark here is an inscribed angle, and it inscribes this arc here separated by these 2 points, so right here. Unfortunately, we don't know the measure there, and we don't know the measure of the central angle, and it's not drawn in. But we do have some other measures. We know that this arc is 116, and this arc is 158. So we could go about solving this problem like we did the last one. We can take 360 degrees, the total distance around a circle, subtract the 116, subtract the 158, and that should get us what's left. That comes to 86 degrees. So this arc measure here is 86 degrees. Now we have enough information to find the measure of the inscribed arc, which is always going to be half of that. So if we take 86 and we divide it by 2, we get 43 degrees. In our next example, now we have some variables. But we still have the same relationships, and we can still set the problem up the same way. So let's look at how we might do that. First thing to notice is that 83 degrees is our intercepted arc, and it intercepts, our inscribed angle, and it intercepts this arc here in orange. So we know that it is equal to 1/2 of that arc. So let's go ahead and set up a relationship showing that. Since we said it's half, we can say that this arc is then equal to 2 times the inscribed angle. So now we can just solve this problem. 2x minus 4 is equal to 166. Just add 4 to each side, and we get 2x is equal to 170. Divide both sides by 2, and we find then that x is equal to 85. So remember the relationship. You can set up an equation to show that relationship. We could have also set it up as 83 is equal to 2x minus 4 divided by 2, like this, 83 is equal to 2x minus 4 divided by 2, since the 83 represents half of its intercepted arc. Let's try a couple more problems. In this example, we want to find the value of x in the given figure. Well, again, we have a relationship that we can set up. Remember that the inscribed angle is half of the arc, or the arc is 2 times that of the inscribed angle. So let's set that up. Notice this time I set it up the other way. I divided the arc by 2 rather than multiplying 2x plus 5 by 2. But it's the same thing. I just chose which way would be easier. So now I can take 25 is equal to 2x plus 5, subtract 5, and we're left with 20 equals 2x. And when I divide by 2, I get an x value of 10. But remember, I could have set it up the other way. I could have set it up as 50 is equal to 2 times 2x plus 5, because I understand the relationship between the arc and the inscribed angle. Let's look at our last problem. Take a minute, pause the video, and see if you can do this on your own. Hopefully what you noticed in this problem is that we have a diameter. And according to the video, anytime we have an arc that intercepts a diameter, it intercepts a semicircle. So this outer arc is half the circle, or 180 degrees. That means that the arc out here relates to this inscribed angle. It is intercepted by this inscribed angle, and so therefore we know that this inscribed angle is a right angle. It's 90 degrees, half of its intercepted arc. Knowing that, we have a right triangle, and we want to find this angle here. Well, we don't know the measure of this arc right here, but we do know the measure of the other arc. Well, look at that in green here. That's 92 degrees. So how can we use that? Well, we can do it a couple ways. We can do it like our first examples, where we take 360 less the 180 less the 92 to determine what this arc is. Or we can take advantage of the fact that this is a triangle, and we can figure out what 2 of the 3 angles are in order to find this question mark. We know that if this arc here, this inscribed arc, is 92, then we know that the intercepted arc is 92, then we know that the inscribed angle is going to be half of that. So if we take 92 divided by half, we get 46. So this angle here is 46 degrees. Now we have 2 out of 3 angles in a triangle. There are 180 degrees in an entire triangle. So if we subtract the 2 angles that we know, we can find our third angle. And it looks like we get 44 degrees. So this angle here is 44 degrees. And we've solved this problem. That concludes our lesson on inscribed angles. So at this point, you should understand the relationship between an inscribed angle and a central angle. You should also know the relationship between inscribed angles that intercept the same arc, as well as be able to solve problems using those relationships.